Greetings to all the viewers. The session is going to conduct with the topic called acridine. Acridine is the part of heterocyclic compound. Preferred IUPAC nomenclature is accorded for the acridine will be acridine itself, and other possible naming is also given over here. Dibenzopyridine, 2,3 benzoquinolone as well, right? So here the compound, if you observe, it is the kind of a triannular system. You can observe three cyclic rings which available. Two are purely benzene, and one is resembling with the pyridine. That's the reason why there is an alternative name. Dibenzopyridine is provided, and the attachment over the phases are also given B and E phases, right? And here is another benzoquinolone. If we take one of the benzene ring as the substituent, and the remaining core molecule will become quinolene. That's the reason why quinolene skeleton or else pyridine skeleton to be considered in the alternative pathways in general. In accordance with the International Union for Pure and Applied Chemistry, it is accorded as acridine, right? So this is a universally applied nomenclature for this heterocyclic compound, and the session is powered by AI, artificial intelligence powered session it will be. And here the naming is provided, numbering is provided for this, where we can start with the benzene ring, and 1 2 3 4 5 6 7 8 and 9 10 is accorded for this heterocyclic ring system. This is in accordance with the anthracene. The molecule is exactly resembling with the anthracene, and the exact nomenclature, exact numbering is provided as per the anthracene numbering system. That's the reason why here is also we have the same kind of numbering system, and the detailed description regarding its chemical composition is provided in this first chemical structure, where the nitrogen is located with the lone pair of electrons, and it is of 1 2 3 4 5 6 7 pi bond containing system it will be, and all the carbon atoms are attached with the hydrogen atoms over there, and the entire system is said to be conjugated in nature, and the heteroatom whichever provided is mentioned with the blue color atom, that is the nitrogen you can denote, and all the ash color lobes indicated for the carbon atoms, and white color lobes manifested for the hydrogen atom. This is the three-dimensional representation without any bond representation, right? So this is regarding the acridine molecule. Let me go with the agenda of the session. Introduction for this compound is provided in the continuation, and the synthetic strategy. How can we go for the laboratory viable methodology for the synthetic protocols to manufacture, to fabricate the compound on the laboratory scale, and what could be the properties in general, how it looks like, and what order it exhibit, and melting boiling point values to be manifested over there, and whenever it is added with certain kind of reagents, what kind of chemical activity is exhibited by the molecule are taken in this segment. And finally we will go with their potential applications, in which field we conveniently utilize this acridine molecule, being it is heterocyclic and moreover nitrogen heteroatom taken part of this one, then what applications we can avail. All these topics to be discussed in the session of acridine, right? A brief intro regarding this acridine is going to be discussed over here. Acridine is an organic compound, being it is made up of carbon, hydrogens, and nitrogen together. It is the part of organic molecule, and moreover, it is the nitrogen containing heterocyclic system, and there are 13 carbon atoms, 9 hydrogens, and 1 nitrogen located within the molecule. So that molecular formula is provided as C13H9N. It is a tricyclic aromatic ring system consisting 3 fused benzene rings. All are 6-member ring systems only, so that all 3 cyclic rings are recorded as benzenes only, but instead of one of the carbon, you can replace with the nitrogen only, right? So here, one of the central carbon atom replaced by the nitrogen atom. Acridine is structurally related with the anthracene. Anthracene looks like a triangular system in the same chemical resemblance you can observe in case of this anthracene, in case of acridine as well. Only the difference is 10th carbon will be replaced with the nitrogen atom. Only the difference being the presence of nitrogen atom in the middle ring system. The distinctive factor among these two molecules will be the nitrogen at the position number 10. This is the way anthracene and acridine related. Even in the numbering system, there is no ambiguity. All are having exact resemblance over there. Only the distinctive factor will be the nitrogen at the position number 10. Significance of acridine. Why we are going to study about this? What could be the importance of the compound? Why we are supposed to go with this in detailed description regarding this molecule? That is significance of the acridine is going to be discussed over here. It is very essential heterocyclic compound exhibited which taken part of this biological important materials like proflavin. Proflavin is the flavonoid. Flavonoids are said to be biomolecules. Everybody aware. So the proflavin is made by this acridine as a core skeleton and accorded with the amino functionalities over the side benzene rings. Sorry. Let me take another molecule as well. Again, it is made by the same kind of proflavin only, but here you can notice it is the kind of an alkylated one, and moreover it is existing in the form of salt as well, right? So this is also another kind of molecule called tripaflavin. Tripaflavin is also there, both together regarded as acreflavins. Acreflavins are the part of what? A flavonoid family. Flavonoids are very essential based extract, we can say, and they are also extracted from the animal sources as well. So many kind of natural ingredients are rich in the flavonoids. They are very essential in the healthy growth of living organisms, so that acridine is the part of that kind of flavonoid family, right? And another significant application of the acridine will be acridine orange. You can observe that it is the kind of acridine skeletal core molecule, and here you can observe a kind of tertiary amine, and here is the kind of iminium salt. A tertiary amine, again same will be repeated, but instead of benzenoid, here you can observe the quininoid nucleus. So this is the kind of acridine orange molecule. It is going to bind with that nucleic acids like DNA and RNA in metachromatic stain, useful in the cell cycle determination, right? It is the kind of diagnostic tool able to determine the kind of staining of those cell cycles, and that is the kind of a coloring pigment it will be, and you can clearly observe how the acridine taken part of this staining agent in the cell cycle determination process. This is the kind of three-dimensional representation of that cell cycling process. Significance of the acridine to be continued. Another important application will be intercalating agent. It will be intercalation is nothing but it able to bind up with the molecules with the certain affinity. Intercalation is possible over there. Intercalating agents produce the mutations by sandwiching themselves, intercalating between the adjacent bases of the DNA that used to fix within the molecule of DNA. DNA, everybody aware about this, is the most important valuable genetic material available in every creature, and this is responsible for all characteristics of that particular living organism, right? So when this DNA strands are taken into the consideration, in between these DNAs, acridine molecules to be sandwiched, they are doped, they are inserted in such a manner by the process called intercalation. They distorts the three-dimensional structure of the helix, especially they are working in the kind of parasitic data destroying process. They are used to attacking on the DNA, and they are able to form intercalated complexes, intercalated sandwiched molecules, so that that double helical structure slowly destroyed in those parasitic animals and those disease causing organisms. So eventually those organisms will be finally destroyed by retarding their replication process, and their growth of that particular genetic matter will be slowly backwarded, and this is the manner intercalation of this acridine giving rise to a kind of biological applications in the pharmacology. These insertions and the deletions frequently produce the frame shift mutation. So the DNA will go through the mutation process, and mutagenic effects of the intercalating agents are often severe, right? So the mutations whichever occurred in the organism, in the persons, that able to give it a severe impact over there. And because intercalating agent generate the both additions and deletions, they can reverse the effect, and their own mutations are possible whenever there is a cell replication, cell propagation is possible, then only healthy survival is possible. Whenever the molecule like acridine is intercalated or inserted in such a manner that able to create the mutations within the living organisms, whenever mutations are created, that particular genetic matter will be injured. Genetic matter will be injured, and that healthy progress may not be possible. That used to avoid that, restrict the growth of that particular organism, especially in the pathogenic organisms like proflavin, acridine orange, ethidium bromide, and dioxin. All are having the property of this intercalation, giving rise to antimicrobial activity. And let me go through the history of the acridine, where the acridine history got started, right? First time isolation of the acridine was started in the year 1870 from high boiling fraction of the coal tar by the Carl Grabe and Heinrich Caro in Germany, right? The eminent scientists, you can observe Carl Grabe and Heinrich Caro together worked upon this kind of acridine molecule in the laboratory. And the year 1870, they collected from the natural material coal tar by boiling fractionation process, fractional distillation is the chemical method, in order to separate all the fractions by means of that fractional distillation process itself. These scientists successfully collected the material called acridine. And further, in 1917, Enrich and Bende discovered the antimicrobial property of the acridine. Initial extraction and isolation got carried by the scientists together, Carl Grabe and Heinrich Caro. Further, the molecule whichever isolated, whichever identified, that got its importance, antimicrobial property was accorded to the acridine, that identified diagnosis of that antimicrobial property was done early in the year 1917 by the scientists, again Orlich and Bende. So Orlich and Benda. This is the way first history of the acridine began, right? Now let me go with the synthesis of the acridine. How many ways are available in order to synthesize acridine within the laboratory? Here is the named reaction for the synthesis of acridine on the laboratory platform. Bernstein acridine synthesis. This classic method involves the heating the mixture of diphenylamine, one of the starting material, and carboxylic acid. This is the aromatic carboxylic acid taken. Usually it is the benzoic acid, and the catalyst applied will be zinc chloride. In order to go for that kind of condensation, elevated temperature is a requisite reaction condition, so that acridine formation is possible by the byproduct formation of water. This is the way diphenylamine can be condensed with the benzoic acid in the presence of zinc chloride catalyst at the higher temperature, giving acridine as the final product. Schematic representation is manifested where we are taking diphenylamine, and here the general carboxylic acid was taken. Zinc chloride is the ingredient added over there. This carbon will be inserted in between, so that we are able to accord the six-membered ring insertion in between these two benzenes, and giving rise to acridine as the final product in addition to the water. This is the way Bunsen acridine synthesis is given, and detailed mechanism is provided. Initially, reaction will be started by using carboxylic acid. Upon reacting with the zinc chloride, that able to give the acid chloride derivative. Acid will be transformed into acid chloride derivative. Moreover, acid chloride derivatives are hyperreactive towards any kind of synthetic protocol, so that acid chloride conveniently go for the reaction towards this diphenylamine, and where the adjacent position with respect to nitrogen binding, this alpha position is supposed to be treated with this acid chloride in the presence of zinc chloride catalyst, giving rise to the acylation. The acylation is accorded at this alpha position with respect to nitrogen substitution, and subsequently we are generating carbocation at this bridgehead carbon atoms. And now let me go with the reactivity of this catalyst zinc chloride to be taking up this hydrogen from this bridged carbon atom in order to restore the aromaticity of the benzene ring. Subsequently, hydrochloric acid and zinc chloride will be departed from the system and giving rise to a kind of aromaticity within the molecule. Later, one more zinc chloride to be operated upon, and that acid chloride, acylated product, whatever we had, that will be coordinated with the zinc chloride. There is a coordination in between the oxygen and zinc metal, and that will participate in the ring cyclization. Being oxygen is more electronegative, pi electrons are simultaneously moving towards this oxygen and generating carbon deficit over this carbonylic carbon atom, which will takes up the electrons from the benzene ring from the adjacent position, giving rise to six-membered cyclic ring system, and that originating the carbocation over the bridgehead carbon atom. And immediately we are supposed to restore the benzenoid nucleus over this benzene ring, so that deprotonation and restoration of the benzene ring will be taken by this hydrogen. Whenever this by this oxygen, whenever this oxygen is accepting the proton, departure of this zinc chloride taken, being it is a catalyst, will not participate in the reaction directly, rather it will facilitate the reaction without participating. Though it is participated, finally it will come out as a byproduct. This is the way catalyst will be restored, and there is a origination of hydroxyl functionality over this carbon, newly bonded carbon atom. Later, hydrochloric acid is taking the reaction with this nitrogen, so that it able to originate a kind of quaternary nitrogen, nitronium chloride, ammonium chloride type of salt formation will be possible. Later, the hydrogen whichever bonded with the nitrogen will generating a positive charge over the nitrogen, which is highly unfavorable, being nitrogen is more electronegative, can't bear positive for charge for the longer time, so that immediately proton will be departed from that one, and that will be taken by the hydroxyl functionality over the position number 10, so that dehydration is the consequence. And here is the aromatization, being by deprotonation, another hydrogen will be removed by the chloride ion, negatively charged species pulling the H positive, and that able to generate negative charge over the nitrogen, that able to participate in a pi bond formation, and another pi bond whichever present in the benzene ring will shift over in order to make the entire conjugated system, so that finally we are able to accord the product called acridine by means of this Benston synthesis process, where the starting material will be carboxylic acid, another will be diphenylamine, zinc chloride will be taken as the catalyst role is very crucial. It is participating directly within the reaction in so many processes, so many steps as well. And finally, acridine is accorded as a final output, right? So this is the way the method of synthesis is accorded. Let me go with the mechanism of the process. In order to synthesize the acridine compound by means of this Bunsen acridine process, mix the diphenylamine with benzoic acid. This will be the step one. Whenever the mixture of benzoic acid, diphenylamine was taken in the reaction vessel, RB flask will be taken. Anhydrazine chloride to be added in the catalytic amount. Catalytic amount means what? Need not to go for the stoichiometric ratio. Quantified addition is not required. Rather, we need to go with the few drops of the zinc chloride, being it is a kind of catalyst, will participate in the negligible quantity, but profound role is operated by the kind of catalyst everywhere. Heat the mixture about 200 to 250 degrees centigrade, being the reaction is accorded, being the reaction is accompanied by so many condensation processes in a several steps. That's the reason why temperature to be optimized to 200 to 250 degrees centigrade range. So this is the way elevated temperature giving rise to byproduct condensation processes, so that acridine synthesis is accomplished at higher temperature. The reaction results in the formation of acridine, and any other product will be water, so that we think the process will be eco-friendly in nature. No poisonous compound will be consumed and released as well, right? Another methodology for the synthesis of this acridine will be cyclodehydration of diaryl amines. Diaryl amine is the starting material to be taken to be operated with the process called cyclodehydration, right? Cyclization, subsequent removal of the water taken and giving rise to acridine as the final product under dehydrating agent conditions. So sulfuric acid is the better water removing agent, so that it is like a dehydrating agent. Acridine can also be synthesized to through the cyclodehydration process of N-phenylanthranilic acid. This is said to be N-phenylanthranilic acid. Under acidified condition, the reaction is proceeded, giving rise to acridine as the final product. In order to record the reaction, let me go with the anthranilic acid. Anthranilic acid will be taken, and sulfuric acid will be treated over, and aryl halide is the kind of condition operated upon, and giving rise to this alkyl halide. When operated with this amine, that able to go with the HX, removal of HX, simply in alkylation we can say. So N-phenylanthranilic acid is the N-phenylanthranilic acid is starting material whichever taken. This is called N-phenylanthranilic acid, what we created by treating with the chlorobenzene, right? So it to be participated in the ring cyclization process. In order to go for the ring cyclization, the requirement will be the dehydration. In order to go for the dehydration, dehydrating agent will be sulfuric acid. Concentrated sulfuric acid to be applied in order to go for the ring cyclization, so that water will be removed between this carboxylic acid and the adjacent benzene ring carbon atom, giving rise to a ketonic functionality over there. The molecule whichever generated is called acridone. This one is said to be acridone. Acridone is supposed to be converted into kind of saturated one by means of reduction process, so that we are supposed to remove this oxygen by the reduction. Removal of oxygen is also regarded as a reduction. So reduction giving rise to deoxygenation. Oxygen will be removed over there. So whenever oxygen removed, we got the molecule with the skeleton of acridine only, but certain extent saturation you can observe. That's the reason why the molecule is not exactly the acridine, rather it will be acridane. This to be dehydrogenated by means of oxidation process. Removal of hydrogen is called oxidation, right? That's the reason why oxidation to be applied over this, that able to remove the hydrogens from the position number 1 and 2, and the position number sorry, not 1 and 2, 9 and position number 9 and 10. That's the reason why here is the completely what we can say aromatic acridine molecule formation is possible. This is the way cyclodehydration said to be. It is the kind of ring cyclization, subsequently elimination of water taken. That is the reason why it is called cyclodehydration process of diaryl amines. Diarylamine. Here is the aryl, here is the aryl, here is the amine located, so that N-phenylanthranilic acid will be the starting material, giving rise to acridine as the final product. And so many methods whichever required, whichever possible in order to synthesize the acridine in the laboratory pathway, all are indicated in the same slide. All these are the schematic representation of acridine synthesis. We will go with the individual synthetic pathways. Already we gone through this method. And this is the one, diphenylamine will be taken and treated with the RCOH, zinc chloride, whatever we are discussing about, that will be zinc chloride addition is required over there. This is the diphenylamine carboxylic acid zinc chloride. This is called Benston synthesis. That process we already gone through. So this one we already gone through, Benston synthesis. And this is said to be what anthranilic acid salt will be taken and to be treated with this cyclohexene alpha beta unsaturated ketone will be treated, and 120 degrees centigrade, giving rise to methylated acridine as the final product. This is the named reaction we will go with. And another one will be a kind of diphenylamine. Again, it is the kind of benzoyl diphenylamine will be taken and to be added with iodine HI, giving rise to phenylated acridine as the final product. These reactions to be discussed in detail in the coming slides. A cyclodehydration aryl diamine process of the synthesis we gone through. N-phenylanthranilic acid is one of the starting material to be treated with sulfuric acid, being it is the dehydrating agent and operated upon diphenylanthranilic acid. Ring cyclization will be the consequence of this one. and the mixture is heated to increasing the temperature. Whenever heated, so the cyclodehydration process will be accompanied by raising the temperature. Acridine is obtained by the neutralization and extraction further. After getting this ring cyclodehydration process, reduction, subsequent oxidation are the consequent steps and giving rise to acridine as the final product. Let me go with another methodology of the synthesis. Orthochlorobenzoic acid. Orthochlorobenzoic acid will be the one of the starting material, and aniline will be the another starting material to be condensed in such a manner under alkaline conditions, so that condensation among the amine and chlorofunctionality is giving rise to hydrochloric acid as the byproduct. So that here you can notice ortho carboxylic acid containing an diphenylamine. This is said to be N-phenyl anthranilic acid as well, or else you can designate the molecule as you can designate the molecule as diphenylamine carboxylic acid. Phosphorus oxychloride will be the reagent added. Phosphorus oxychloride is the reagent treated for. It is meant for dehydration. Phosphorus oxychloride is the efficient dehydrating agent. Under heating conditions, it will go with the ring cyclization, subsequently dehydration as well, giving rise to chlorofunctionality over the position number 10. 9-chloroacridine formation is accomplished by means of this orthochlorobenzoic acid starting material. Let me go with whenever this 9-chloroacridine is the 9-chloroacridine will be there, that 9-chloroacridine to be treated with hydrogen in the presence of nickel. That hydrogen nickel is the kind of metal mediated reduction process is operated over. So the chloro is immediately removed, giving rise to a kind of certain extent of saturation over this acridine, which is said to be dihydroacridine. The molecule whichever originated is called dihydroacridine. But our intention to be acridine, pure acridine formation, so that oxidation is the next step. In order to go for the oxidation, Lewis acid ferric chloride to be applied. Whenever ferric chloride applied over this dihydroacridine, that to be reduced in such a that to be oxidized in such a manner, removal of the hydrogens taken and acridine as the final product. This is the way orthochlorobenzoic acid is also the starting material for this acridine synthesis. Friedlander synthesis is also possible. This scheme we already observed in that entire scheme representation. Now let me go with the detailed description regarding this Friedlander synthesis for this acridine molecule. In order to synthesize Friedlander acridine process, let me go with the anthranil only, but antranilic acid to be taken in the form of salt. That is called antranilic acid. Salt will be taken as one of the starting material, and alpha beta unsaturated ketone. This is said to be cyclohexato-enone. So this is the conjugated system. Conjugated system it will be, and treated at the temperature 120 degrees centigrade. Whenever this heating is required, what it will do, that will obviously go with the ring condensation with nitrogen and this carbon atom by removal of water molecule, and you will get again a kind of ring structure over there. This N-alkyl, this nitrogen double bond, this entire ring system will be condensed over there. That iminium intermediate will be originated. Later it will go with the rings dehydration cyclization as well. So, and further oxidation process giving rise to a final product, that is acridine as the final product, 9-methyl acridine as the final product. This is the way we will go with the cyclohexane to enone will be treated with this antranilic acid salt, giving rise to this 9-methyl acridine as the final product. Let me go with another methodology for the synthesis. This scheme also we already absorbed in that entire schematic synthetic protocols. Here is the kind of molecule said to be phenyl, 6-phenylaminocyclohexa dienylmethionine, right? So this one is simply benzoyl diphenylamine. So this is a benzoyl nucleus over this benzene ring, right? So this benzoyl is present on benzene, and this is called diphenylamine. Benzoyl diphenylamine is the starting material to be treated with this iodine and hydroiodic acid. Iodine dissolving in the hydroiodic acid and rising the temperature to the higher, that able to participate in the ring cyclization. So initially, Hopefully the molecule will go with the kind of alkyl group shift over there. Later on, it will participate in the ring cyclization, giving rise to 9-phenylacridine as the final product. 9-phenylacridine formation is possible. The reaction base is accomplished by means of a first acylation. First acylation is performed on diphenylamine. Diphenylamine will be the starting material that is prone to participate in the acylation, so that this benzoylation is accomplished at this position. A thermochemical reaction producing 9-phenylacridine by heating acylated diphenylamine in the presence of iodine HI, giving rise to this final product. This is the way C-acylated product is also there. Carbon acylated product is also there, that will go with this acridine formation, right? So by means of this one, we completely gone through this various methodologies for the synthesis of acridine. Let me observe the properties of acridine molecule. It appears like a yellow crystalline solid, right? Acridine looks like a yellow crystalline solid, that is mentioned over here. Mild and characteristic odor will be there, being it is made by the nitrogen containing compound. A certain extent of characteristic odor is the common criteria for that one. Slightly soluble in water, being it is the polyannular system, more number of carbons giving rise to more non-polarity for the molecule, and least solubility in the water and the most solubility in the organic solvents like ether, benzene, chloroform, carbon tetrachloride, toluene. These are the suitable solvents in order to dissolve the compound in these organic solvents. It melts at the temperature 110 to 112 degrees centigrade, right? So that at room temperature, conveniently, it will be solid only. That's the reason why temperature beyond 100 only it able to melt. So that 110 to 112 range temperature melting point is accorded. Boils at the temperature 346 degrees centigrade. It is extremely larger, so that it is non-volatile solid it will be, right? If you observe the chemical properties of the acridine, acridine is the kind of polyannular system in general, where you can notice benzene ring, pyridine ring, again benzene ring over there, tricyclic system. Acridine is the aromatic heterocyclic compound in interesting chemical properties due to its structure. It's a structure responsible for its chemical reactivity. Here are some of the most important chemical properties of this acridine are manifested, right? Aromaticity is the common criteria for most of the heterocyclic compounds, so that acridine is also the part of this heterocyclic ring system. And there are 3 fused rings, and all are perfectly obeying this kind of aromaticity. Benzene and pyridine rings all are perfectly aromatic in nature, and they are obeying the focal rule, aromaticity rule, that is 4n plus 2 electron system are located for this one, and contribution to its stability and planarity. The entire molecule is a planar in nature, flat molecule it could be, and stability is exceptionally high, being it is aromatic in nature. Acridine is a ring system with 13 carbon atoms and 1 nitrogen within the triannular system. All are participating in the sp2 hybridization process. Two sp2 orbitals atoms overlap each other to form the carbon-carbon bonding and carbon-nitrogen bonding as well. All are participating. This kind of hybridized orbitals are responsible for the sigma bond formation, whereas each carbon atom and nitrogen are accompanied by the unhybridized p orbitals as well. They are participating in the lateral overlapping, giving rise to pi bond formation as well. This is the reason why there is the existence of alternative double and single bonds. Conjugated system, ring system will be there, and sp2 hybridization, planarity, all these are requisite qualities for the aromaticity for this compound, so that it is accorded with this 4n plus 2 pi electron Huckel rule obeyed by this, and it is aromatic in nature. If you observe the basicity of the acridine is conveniently basic, but the extent of basicity is somewhat lesser. The strength of basicity is somewhat lesser in comparison to any other heterocyclic compounds, being lone pair of electrons upon the nitrogen not freely valuable. That is because the negative I effect, that means minus the inductive effect of the benzene rings, whichever directly attached to this pyridine ring, they are destroying the electron density upon the nitrogen, so that nitrogen is not freely releasing the electrons as pyridine is giving. That's the reason why basicity of this acridine is somewhat lesser, weaker. and whose pKa value is quantified as 5.6. It is indicating weaker base than pyridine. So when you observe the pyridine and acridine together, pyridine is having the free location of the nitrogen, and nitrogen electrons not that influenced by inductive effect by adjacent ring system. There are absence of ring systems you can observe. But in acridine molecule, the pyridine now covered with two ring systems, and ring systems having electron withdrawing tendency. They destroy the electron density upon the nitrogen. That's the reason why electron density diminished in comparison to the pyridine. That's the reason why pKa value is a proof for that one, and it is giving somewhat lesser value. 5.6 is indicated for this one, and sufficiently basic to be reacted with the hydrochloric acid and giving rise to acridinium salt as well. But the extent of reactivity, ease of reactivity is certainly less than this pyridine. Let me go with the 9-amino acridine, and again it will go for the kind of reaction with hydrochloric acid. It is the evidence for its basicity. Nitrogen is basic due to the availability of electrons towards this protonation process. The protonation, electron donation towards this proton, giving rise to a kind of salt formation. So here is the nitrogen capturing this proton and a positive charge accorded and counterbalance with the negative chloride. At the same time, you also observe there is a amino functionality over the position 10 that also equally reactive towards this hydrochloric acid, giving rise to a double salt. Double salt of this 9-amino acridine is the consequence whenever amino functionality is located upon the acridine, being two nitrogens are reactive towards the hydrochloric acid. This is the way basicity of the acridine got proved. Lone pair of electrons is the driving force for this basicity. And there is a nucleophilicity. There is a difference between the basicity and nucleophilicity. Basicity stands for release of electrons towards the proton, and nucleophilicity stands for that able to form able to give the electrons to the species towards the electron deficient one. It able to react with the electron. The nucleophilicity stands for the electron richness. High electron density around that one, that electron density able to bind up with the electron deficit species, right? So this is the way nucleophilicity also matters for this acridine. That's the reason why it able to bind up with the alkylating agent. So that alkylation is the consequence of that one. Protonation will be taken because of its nucleophilicity, because of its rich electron density over the nitrogen. Nucleophile stands for more electron density. Electrophile, electron deficit species. This is the way nucleophilicity of this acridine nitrogen responsible for this N-protonation, and moreover N-alkylation is also the possibility over there, right? So this is the evidence for the nucleophilicity of the acridine nitrogen. Electrophilic substitutions are possible. This is the common characteristic of all the aromatic compounds, whichever said to be aromatic, branded reactivity towards the electrophilic substitution in general. That is because entire aromatic rings are electron rich sufficiently in order to capture the electron deficit species and go with the electrophilic substitution reactions in general. Being it is aromatic in nature, that's the reason why acridine is able to participate in the electrophilic substitution reactions, but the reactivity in comparison to the benzene is certainly less. That is purely because of the presence of the nitrogen, but nitrogen is obviously electron deficient in nature, having the tendency to drag the electron density toward that, so that electron cloud density on the acridine is somewhat less. Examples towards the electrophilic substitutions are nitration, chalconation, and halogenation. These reactions are conveniently operated over this acridine. Preferred position for this electrophilic substitution will be 9 at this aromatic ring system, heterocyclic ring system only. Whenever nitration is operated upon this pyridine ring, acridine to be first is supposed to be go for this inoxidation. Inoxidation is protecting of this nitrogen, so that whatever you want to operate, let me go with the nitration process. Nitration will be accomplished at the position number 9. In addition, there is a provision for this electrophilic substitution at the position number 2 and 7 as well, right? So these benzene rings are also susceptible for this nitration process and bromination as well. at benzenoid rings in addition to the pyridine. Pyridine nitration is also possible, right? At the same manner, the nitration will accomplished over these benzene rings at the second and seventh positions respectively. Either you can operate with the nitration or else bromination. They will give rise to multiple products like this, right? So nitration is carried by adding this nitrating mixture like concentrated nitric acid and sulfuric acid is operated over this acridine, giving rise to dinitro-acridine as the final product. At the same time, bromination dissolving bromine in the glacial acetic acid, giving dibromo derivative of the acridine. And let me discuss about the reduction reactivity of the acridine. Acridine will go with the partial and complete reduction of these benzenoid rings as well. That depends upon the type of catalyst operated over, and the acridine is supposed to be treated with zinc hydrochloric acid or else sodium dissolved in the alcohol to be operated upon the acridine, and there is a selective reduction of the heterocyclic ring without affecting the benzenoid nucleus and giving rise to dihydroacridine as the final product. So this is one kind of partial oxidation process. Again, palladium hydrogen reduction will be operated upon the same acridine, giving rise to selective reduction of the benzenoid nucleus without affecting the heterocyclic ring system. This is said to be octahydro. If all the benzene rings supposed to be reduced, that is octahydroacridine as the final product. This is the way reduction will be manifested over this acridine molecule. And continuation to that reduction process, acridine to be reacted with the hydrogen platinum. Here palladium, instead you may go with another transition metal called the hydrogen platinum dissolving in the hydrochloric acid. It working like a catalyst together, platinum and hydrochloric acid together working like a catalyst over, and these are again selective for this aromatic ring, benzenoid ring reduction, just like palladium. Both are resembling with the same kind of reductivity ability. Let me go with the zinc hydrochloric acid. Zinc hydrochloric acid is more selective towards this heterocyclic ring reduction, right? Dihydroacridine formation is possible. This is the way a reduction reaction will be manifested. Let me discuss regarding this oxidation process. Just like a kind of heterocyclic systems, here is also the provision for the oxidation process upon the acridine. Multiple reagents will be operated over the acridine, giving rise to multiple oxidized products as well. Whenever acridine is supposed to be reacted with alkaline CaMnO4 solution, being it is a strong oxidizing agent, benzene ring totally destroyed, and wherever joining carbons are there, they will be subsequently converted into dicarboxylic acid derivative. This is said to be quinoline 2, 3 dicarboxylic acid. Quinoline dicarboxylic acid will be one of the oxidized product by means of CaMnO4, potassium permanganate oxidation. Let me dissolve in the sodium dichromate in glacial acetic acid, that able to give a kind of ketonic functionality over the position 10, which is said to be acridone. So this is the way multiple product formation is are possible by using various oxidizing agents upon alkaline CaMnO4, giving rise to dicarboxylic acid of this quinoline, and potassium dichromate dissolving in the glacial acetic acid, giving rise to acridone as the final product. This is the way acridine oxidation is possible. And there is a provision for the Chichi-Babin reaction. It is the part of nucleophilic substitution, being the position of this, what we can say, acridine molecule is supposed to be treated with the strong nucleophilic reagent, that is sodamide dissolving the liquid ammonia, generating the amide fragment over there. That will be the NH2 minus will be the kind of nucleophile is operated over the position number 10, giving rise to 10 amino acridine as the final product. This is the when nucleophilic substitution is also matters wherever H negative will be replaced with the NH2 negative. This is the part of nucleophilic substitution reaction, and this is said to be Chichi-Babin reaction. Fluorescent activity is also the kind of chemical reactivity exhibited by the acridine molecule. Acridine and its derivatives are exhibiting the fluorescent activity, being it is the kind of polyannular system, and more conjugation is available and able to capture the light and give the light. Capturing and emitting light in the visible region, especially UV visible region, that able to generate this fluorescence. Fluorescence is possible that is useful in the biological staining and fluorescent microscopy as well. So whenever fluorescent light is emitted by these molecules, they are working like dyes in the microscopic investigations in the analytical chemistry as well, and the tiny organisms easily identified by using such a kind of fluorescent microscopy technique. And here is the another property exhibited by this acridine called the tautomerism. Tautomerism is the kind of structural isomerism. It is taken by interchanging the position of the functionalities within the system. It is the kind of rearrangement we can denote. And here is the kind of molecule you can observe where we are having a particular aromaticity within the molecule entirely. This is the one amino functionality over the position number 10 will participate in this tautomerism process. Whenever nitrogen containing lone pair of electrons taking part of this double bond formation, so that the adjacent bond will be shifted towards the adjacent carbon atom. Whenever the bond is moving over there, then the electrons whichever present on this present in between the nitrogen and carbon taken up by this nitrogen, so that what happens here is the generation of the imino functionality, and imino nitronium ion formation is possible, and whichever positive charge already existing upon the first nitrogen will be disappeared. This is the way kind of delocalization of the pi electrons, giving rise to interconvertible to tautomers. This is the process said to be tautomerism. Tautomerism represented by this kind of delocalization of the electrons and two possible interconversions you can observe. And the same manner, if you're having a kind of a quaternary nitrogen over there, and that will participating in a double bond formation, and double bond formation is possible, and that also able to give a kind of tautomer over there. This is the way tautomerism is a kind of behavior exhibited by the acridine whenever it is substituted. Here is the substitution, here is the substitution you can observe, especially at the position number 9. Then it is very convenient to go for this tautomerism process. By this, we successfully accomplished the entire chemical property exhibited by this molecule called acridine. Now, let me discuss regarding the applicability of this acridine molecule in various dimensions, like pharmacological activity and material chemistry applications, and various kind of platforms are utilizing this acridine molecule because of its higher potential for the applicability. Let me go with this kind of application purview regarding the acridine. Here, proflavin, which we already observed in the significance of the acridine molecule, proflavin is a kind of antiseptic agent, just like a Dettol. Dettol is the disinfectant, right? So, antiseptic agent, right? Every time after doing any kind of work before going to meal, we are supposed to wash our hands in order to remove the microbes over there. That is the disinfectant antiseptic property of this one. That antiseptic property can be resembled by the molecule called proflavin, which is indicated over there. It is a kind of acridine. You can locate the amino functionalities over the benzene nucleus. This is the molecule which is indicated with this B, which is called proflavin. In addition, we are also having acroflavin and quinacrine as well. These are also having a kind of antiseptic properties. These are also the analogs of acridine molecule as well, right? So proflavin is more proficient in case of antiseptic property. And another property regarding this, another application regarding this acridine is a kind of molecule which is composed by this acridine skeleton is amsaccharin. Amsaccharin skeleton is provided where acridine taken as the skeletal core moiety, and it able to bind up with the DNA and RNA conveniently due to their ability for the intercalation. Intercalation is a specific activity by the kind of this acridine molecule. So many times the word is repeated in this kind of discussion, intercalation process. Intercalation mean for reversible insertion of the molecules or ions into the layered materials that will be inserted in between. Whenever layers of the molecules are present, it will be inserted in general. Graphite or transition metal dichalconides. So whatever materials are arranged in particular manner, the material, this acridine having ability to insert, ability to fix inside whenever the kind of DNA DNA, various strains are available in the layered structure. Now this acridine that amsacrin having tendency. Amsacrid is the drug which is having the tendency to insert inside. This is the way intercalation is possible. Whenever intercalation is possible, this DNA activity is slowly diminished and it will be totally destroyed. Right. So this is the way pathogenic replication will be totally avoided, totally retarded by means of the drug called the saccharin, which is composed by the acridine-Dibenzopyridine-Heterocyclic. You can clearly observe this is the acridine part, and here is the amino linkage, a secondary amino linkage with the benzene nucleus and methoxy functionality. And here we are having sulfonamide. In general, we can say sulfonamide, obviously having antimicrobial activity. So many times it is the proven commercial drug. It will be sulfonamides are very potential in destroying the microbial microbes, right? So the again intercalation process is manifested over there wherever acridine molecule and DNA intercalation is the specific property indicated by this molecule, especially in the cancer cells. Whenever cancer cells are replicating multiple times, what happens? This acridine is going to work upon, and that used to work upon the DNA of that particular cells, whichever propagating uncontrollable way. So that DNA regulation is successfully accomplished by this acridine molecule called amsacrin. Amsacrin is the very potential anti-cancer agent because of its intercalation property. It will fix upon the DNA and regulate its activity. Acridine orange is the kind of pigment or coloring agent you can clearly observe. This is in its chemical name. It is provided with 3,6 dimethyl aminoacridine. It is the chemical naming system for this acridine orange, and which is the nucleic acid selective metachromatic strain used for the cell cycle determination. Cell cycle diagnosis process is accomplished by this compound whose chemical composition is provided. It is a triangular acridine system with this amino linkages at benzenoid nucleus, and its staining process is manifested over there, and how the cellular cycle is possible, that is also provided for the better reference. This is the way acridine orange is very essential. Applicability is accorded for this one. It is applicable in the cell cycle determination process. And antimicrobial agent, it will be which proflavin is the kind of antimicrobial. Obviously, it is intercalating agent. We already discussed regarding. And whichever proflavin intercalating activity is there, that will bind up with the DNA of those microbes, especially bacteria, so that bacterial growth will be trenched out, and that giving rise to potential antibacterial activity, especially working like an antiseptic agent. That's the reason why proflavin is the better antiseptic agent, because of its antibacterial activity. They will kill the bacteria. Another anti-malarial activity is also given the advantage towards these acridine molecules. The marketed drug will be quinacrine. Acridine derivative, it will be where you can locate the acridine nucleus, and chloromoiety. Chloro functionality wherever present. Obviously, there is a pathogenic destroying nature is the advantageous factor you can look at. That's the reason why chloro functionality observed over the acridine molecule, and methoxy is also the kind of, in terms of structure activity relationship purview, these are very potential towards killing the pathogenic microorganisms. And here is the secondary amine with the long chain of the alkyl, and with the tertiary amine with the CH2 certain extent of branched tertiary amine system is also observed over there. This is the way the molecule whichever present, which is said to be quinacrine. This quinacrine is a very potential towards this kind of a female Anopheles mosquito. This is responsible to induce the malaria fever. Malaria fever effectively curated by means of this quinacrine. Quinacrine is the kind of drug made by this acridine, right? So the entire life cycle of malaria parasite in the living organism, how they are inducing the malaria, how it badly impact the immunity system, the entire life cycle process is manifested in this slide. Now, applications are extended towards the anti-tumor activity and the anti-cancer as well. There is amsaccharin, whichever taken as the intercalation property of this kind of acridine molecule, where you can locate the acridine and sulfonamide moiety that is efficient towards reducing the propagation of the tumor cells, so that it is the chemo selective agent, chemotherapeutic agent, and they able to retard the replication and transcription of the DNA of the parasitic organisms, whichever transmitting, whichever propagating the cancer cells, so that cancer cell propagation will be totally destroyed by means of this drug called amsaccharin, which working by the process called intercalation between this DNA and RNA. They are able to bind up with these nucleic acids, so that regulation of that cell propagation will be possible. Anti-protozoal agent, it will be a kind of a protozoans. Protozoans stands for unicellular microorganisms, will be there inducing so many multiple diseases, especially Anopheles mosquito, that is also the kind of medium to spread the kind of malaria disease. There also we are having Plasmodium, that is also the protozoan, a kind of protozoan only. The infection which is created is also the part of this anti-protozoal agent only. So acridine is having the kind of anti-protozoal activity as well. And now let me discuss regarding the biochemistry applications of this molecular biology and biochemistry applications of acridine molecule. DNA RNA staining is possible. Acridine orange is used to fluorescent dye that able to bind up with these kind of nucleosides, so that it is possible to diagnose these DNA and RNA skeletal structure compositions. Dye and pigment. Obviously the kind of molecule whichever taken acridine is having a kind of coloring agent. Whenever it is in the light, that able to absorb the light, and complementary light will be emitted back, and a certain extent of color characteristic exhibited by molecule. Acridine orange is the kind, and proflavin is also the kind of coloring agents. They are able to induce the colors, so that they are working in a dyeing industry as well, especially in the textile industry. In order to impart the various colors to the system, they are working like a coloring agents, like dyeing agents as well. And here, biological staining is possible, especially in the histology and microbiology. Histology stands for the analysis regarding the tissues. In the tissue technology, these are the very tiny organs of the living organisms, and these kind of acridine molecules, whenever inserted inside, they are able to bind up with these kind of very tiny molecules, and what kind of mechanism operated within these tiny organs we can absorb by means of their fluorescent activity. They are having a kind of fluorescent activity we already aware about. That's the reason why the kind of acridine molecules are able to bind up with these tiny cells, and we can analyze, we can diagnose what function they are having, what a deficit or what a kind of damage we have, or else they are working in a proper manner. That kind of analysis is possible by means of this biological staining process by means of acridine, right? And another fluorescent dyes are available, and they are working in a flow cytometry and microscopy as well, right? So in order to operate with the tiny cells and tiny microorgans, it is very essential to use a kind of glowing agents. The glowing agents which are fluorescent in nature, very essential to bind with them, so that we can visualize the molecules which are very tiny in nature, right? That's the reason why these fluorescent dyes, already acridine is having the common fluorescent property, that they are able to bind with these cells, especially in the cytometric process. So it is possible to visualize the molecules, though they are very tiny. It is convenient to observe the normal visible eye in this qualitative and quantitative technologies. And even these fluorescent pigments, fluorescent dyes, fluorescent coloring agents are very applicable in the titration process as well in the analytical chemistry. And they are able to change the color by adding with any other chemical component, so that it is possible to operate the analytical process by adding these acridine-based dyes as indicators. Organic synthesis, these acridine molecules are very essential. The acridine take as a key synthon in order to manufacture multiple pharmacological agents like anti-cancer agent can be fabricated conveniently by introducing coumarin over this acridine, and here anti-malarial agent will be inserted by blending this acridine with this quinoline molecule over there. This is called quinacridine. And here is the acridine bounded with the lengthy chain of alkyl over this benzene molecule DNA or duct it will be. And here is the antimicrobial, antibacterial agent is manufactured starting from the acridine. This is the way key synthon it will be in order to fabricate multiple pharmacological agents within the laboratory. And acridines, they are also extended with the various chemical transformations in the industrial viable pathway in order to go for the propagation of organic synthesis. Multiple components may synthesize starting from this acridine conveniently. By this, we successfully accomplished the entire session pertaining to this acridine, which is a heterocyclic compound. And we are conducting series of heterocyclic compounds in the earlier sessions. All are available at the channel World of Competitive Chemistry. And its link is provided over here. Whatever entire channel link you want, that is provided. Hopefully, the session is very informative. It is covered with the reliable information taken from the authentic sources of various websites. And moreover, AI powered session it will be. This will give the informatic content towards the researchers, those who are working in the field of organic chemistry and pharmaceuticals, and researcher scholars, academicians, and competitive exam seekers, and entrance examination who are seriously preparing about. So everybody, the kind of content is very much informative and useful. Hopefully this session everybody enjoyed very well. Thank you very much for the opportunity. Thank you, one and all.